Hello folks, let's take the part 5 video of this miscellaneous exercise. We are coming to the question number 13 where they give us this data, and from this data they are asking us to show that A, B, C and D are in a GP. So let's see now how we can find out whether it is in a GP or not. So for that what we will do is, as we had seen in some of the earlier problems, we are using our idea of componendo dividendo, and it's with the help of that we are able to get that this happens to be in a GP. So let's take the given. From the given we have a plus bx by a minus bx, b plus cx, b minus cx, c plus dx, c minus dx. To this we are applying componendo dividendo. That is numerator plus denominator and denominator minus numerator minus denominator. I hope we remember numerator plus denominator, numerator minus denominator everywhere. So a plus bx plus a minus bx, then a plus bx minus a plus bx, b plus cx plus b minus cx, b plus cx minus b plus cx, c plus dx plus c minus dx, c plus dx minus c plus dx. So you have px cut, a cut, cx cut, b cut, dx cut, c cut. So you have 2a by 2bx, and you have 2b by 2cx, you have 2c, 2dx. All this can get further cut. And amongst ratios, when you take, suppose if you take the ratios, overall you can have the x also cut. So like that we are left with a by b equal to b by c, that equal to c by d. And that is exactly that happens whenever you have things in a GP. So that is why a, b, c, d are in a GP. That's how we get it. Okay, about the next problem, they say that there are n numbers. There are some n terms which are such that they are in a GP, and all this happens, and then S is the sum, P is the product, and so n terms means it will be AR squared till AR raised to n. This is what we know. So sum, here the sum is A plus AR, like that, isn't it, always? So that we need not write, we know it directly, that it is A into R raised to n minus 1 by R minus 1, assuming that R is bigger than 1. Now product will be A into AR into AR squared, AR raised to n. All these A's, if we multiply, it will become A raised to n. And R, when the bases are same, you can add up the powers. So it will be 1 plus 2 plus till n minus 1, and that by our formula we know it is n into n minus 1 by 2. That's about P. We have got S, P, then R is the sum of reciprocals. That means 1 by A, 1 by AR, 1 by AR squared, and so on, 1 by AR raised to n minus 1. Now we cannot do anything over here till the denominators are equal. So let's equalize the denominator to the LCM, which comes up to this. So what will happen? This has to be multiplied by AR raised, it has to be multiplied by R raised to n minus 1, both in the numerator and denominator. Here by R n minus 2, R raised to n minus 3, and so on. Everywhere you have got to get multiplied by some number so that it becomes equal. So here it is R raised to n minus 1, R raised to n minus 2, R raised to n minus 3, and so on till 1, and denominator is common. Now this is a GP. How with A as 1 and R, common ratio as R, you could apply A into R raised to n minus 1 by R minus 1. So what will come? A is 1, R raised to, there are n terms, so therefore it will be R raised to n minus 1 by R minus 1. Though this is n minus 1, there is a term 1, that way totally there will be n terms. And then of course there is this AR raised to n minus 1, which is already there. And this is how the terms are. Now we will try to see it in the terms of what we require. See, from S Now let's see what is s raised to n. Means it is a raised to n, r raised to n minus 1 whole raised to n, and r minus 1 raised to n. Everything raised to n. Whatever s in s, whatever was there, everything we have raised to n. Then we require p squared. So let's see what is p squared. P squared means whatever is there, that is will get a power 2. Whole to the power 2. So this 2 power will get multiplied. So it will become a raised to 2n, r raised to n into n minus 1. That 2 and this 2 can cancel. Then we have, what's that, r raised to n. R raised to n means everything over here raised to n. That is, this everything is raised to n. That means sorry, a raised to n, r raised to n into n minus n, everything is getting raised to 1. That way. Let's consider the p squared r raised to n. I can borrow some place from here. Now, also p squared r raised to n. Let's check what it is. A raised to 2n sorry, so many things are there, out of which this can be solved, this can cut. So what will happen? A raised to m by a raised to n, a raised to m minus n. So it is a raised to n into r raised to n minus 1 whole raised to n by r minus 1 whole raised to n. Quickly check this. S squared, s raised to n, yes, it is the same. Correct. That's exactly s raised to n. Hence proved. That's about those terms. Now once we are done with that, we are moving to the 15th problem, which says that there are some terms in an AP such that the pth term is A, qth term is B, and rth term is C. If that is the case, they ask us to show that particular thing. So let's check. Here, A and D as usual. So A plus P minus 1, let's take it capital, is equal to A, then A plus Q minus 1D to be equal to P, then A plus R minus 1D to be equal to C. So here let's consider Q minus R times A. So that will be A times Q minus R plus P minus 1 into Q minus R times D, then R minus P times B. So A times R minus P plus Q minus 1 times R minus 1 times D, then P minus Q times C means A times P minus Q plus P minus Q into R minus 1 times D. So it is for us to add it up. So let's add up both sides. So this is what you require, and let's see what it is. Here it is A common. So let's take all the uncommon things inside the bracket. Right, and here D is common. So let's take the uncommon thing inside the bracket. Right away we will also expand. Okay, PQ, then minus PR minus Q plus R, then next term QR minus QP minus R plus P, then PR minus P minus QR plus Q. Then let's see what is happening when we plus R minus P, everything is cutting. Here also PR and PR, P and P, Q and Q, then QR and QR, QP and QP, R and R, everything is cutting. So A into 0, D into 0, the expression is 0, and that is what is being asked to show. So that is about this expression as to how we are getting this. That's all in this video. With the remaining problems, we come in the next video. Thank you.